Hey everyone, Mrs. Garcia here. Today we're going to be looking at notes 1-2, attributes of functions. So I want to first make sure that you have your name in the upper right hand corner in pen. Okay, let's get started. So a x-intercept is a point at which a graph crosses the x-axis, while a y-intercept is a point at which a graph crosses the y-axis. Now I know you already knew those things, we were just refreshing. So let's look at some examples. So find the x and y intercepts of each given relation. Okay, so all we're going to talk about today is the graphical aspect, and then on the next video we'll talk about algebra. Okay, so like I said, I've got this graph here. So we have this equation, this linear equation that's already, thankfully, in slope-intercept form, y equals mx plus b. And I've went ahead and I've graphed it. So I've taken the -1, which we know is the b, which is our y-intercept, and I've plotted it. And then I looked at the slope 1/2, and specifically a positive 1/2. And I knew from my y-intercept that meant I rose 1, and then I went right 2. I went up 1, and then I went right 2. And then I didn't just want to have the minimum number of points. I didn't just want to have 3 points. I wanted to have more. So I went back to my y-intercept, and to stay in line with these other 2 points here, I went ahead and made a couple more points by going down 1, left 2. And remember, why is that legal? Because down is a negative movement and so is left. So if you go down and then you go left, that's a negative over a negative, which makes a positive. And again, I promise you that I graphed this using my straight edge here. Okay, and I put arrows on both ends. And also what I did is I checked myself by looking at the slope again, saying, okay, self, that is a positive slope, which means if I read the graph from left to right, this graph should rise, and it does. Okay, so now that we've gone through the graphing and we made sure that everything's good there, let's talk about finding the x and y-intercept graphically. That's all we're doing today. So graphically, the x-intercept is the point at which a graph crosses the x-axis. So where does this graph cross the x-axis? And that place is here at this ordered pair 2, 0. Okay, so graphically, I've got my x-intercept. My y-intercept, I know you already knew because this was in slope-intercept form, so -1. But you really want to list it properly. But let's just look at the graph just to visualize it. So is this point the point at which the graph crosses through the y-axis? And the answer is yes. So that ordered pair, because we're always going to use that proper notation, is 0, -1. That's our y-intercept. So like I said, this is the only one we're doing today because I think this is a fairly easy concept. And we'll come back tomorrow or whenever you watch the next video, and we will talk about algebraically finding the x and y-intercept. Okay, so hopefully you've got the tools to do it graphically. So now let's flip to the back and let's talk about min and max values. So a minimum value of a function on an interval is the smallest, or really the lowest, y value for the x values in the interval. Okay, and we'll explain more what that means in a minute. So a maximum value of a function on an interval is the greatest or highest y value for the x values in the interval. And I did those quotation marks because that means you rewrite what you have here. Okay, so let's talk about what that means. So we're talking about a function on a given interval. So here we do have this function or this equation, y equals 2x minus 2. I haven't graphed it yet. And I do have this given interval. So notice the interval, obviously it's an interval notation, right? This interval is, notice here, for the x values in the interval. This is a domain, okay? So this is a domain, these are x's. And also what I want you to notice is these are brackets, okay? They're not parentheses. So that means that the value of -1 is included in the interval. The value of 3 is included in the interval. So you'll notice that I already made a domain, quote unquote, of -1 to 3, right? That would be going from -1 inclusive. I have the bracket, so this is a solid line, not a dashed line, all the way to 3 inclusive. Again, I have that solid line and not a dashed line. So now I want to see what the graph looks like, and specifically I want to see what the graph looks like within that interval, okay, within that domain. So let's graph this. We have a y-intercept of -2, so I plot that point first, And then my slope is 2 over 1, positive 2 over 1. So that means I'm going to rise 2 and go right 1 because it's positive slope. Rise 2, go right 1, rise 2, go right 1. And again, I don't just want the minimum number of points, and especially for these, you'll see, you'll want to continue the graph as far as it'll go, as far as what will fit on the paper. And then of course I'm going to use my straight edge, and I'm going to draw my line and my arrows. And then again, I'm going to examine the graph, but specifically I'm going to examine the graph within that interval. And I'm going to find the minimum value on the interval that was given, which is the smallest y value for the x values in the given interval, and I'm going to find the maximum, which is the greatest y value for the x values in the interval. So what does that mean? Really, it just means that I want the lowest point and the highest point either within or on the boundary of that interval. And again, I include the boundary because those were brackets and not parentheses. Okay, so what is the lowest point within that interval? Okay, and hopefully you will say this point right here is the lowest point within that interval, right? And remember, I can use this point on the border because it's a solid line because that was a bracket there. And then what's the highest point within this interval? Well, hopefully you'll say this is the greatest or the highest point within that interval. Okay, and again, I can use the boundary because this is a solid line because that's a bracket. So how do we write the answer? So that's a great question. So we're going to say the minimum value, and here's how we're going to write it. We're going to write it in function notation, and you'll see why later, but that's what we need to do. So this ordered pair right here is the ordered pair -1, -1, 2, 3, 4. So I'm going to write f of -1 equals -4. -4 is my lowest y value within the given interval. And then max, my max, we're going to write f of, it's this point, so that's 1, 2, 3. So f of 3, when my input is 3, my output is 1, 2, 3, 4, positive 4. And that's the highest y value within this interval, including on the boundary. So that is how you find the max and the min, or the min and the max, given a graph. And that's all we're going to do for today.